Okay, this was the code that was proposed to you. From what I've seen, some of you were able to identify the problems. So I have here this function defined as returning an integer and taking an integer as argument, and I have the function pointer defined in a different way. So one thing I need to do is to change the definition of the function to correspond, the definition of the function pointer to correspond to the definition of the function. They should match. And I should adjust the calling, the function call in order to have an integer argument and returning a value. By the way, there's an error here. Change this to, there was an extra space inserted here. This should be val a equal fp2. And so these function pointers are a very powerful tool in C programming. I would like here just to recall the main concepts related to function pointers. So a function name is a symbol that represents an address in memory. And the function pointer are variables that point to an address, and that address can be data or code. If an ordinary pointer that is a pointer that points to data, as it is here, that's what, let's say, that's most common use. But we can also have function pointers, which are variables that point to code. The syntax is the logic of the syntax is the same. We use the star before the name to denote a pointer. The only catch is that we have to use parentheses, brackets around the name to make the association of the star to the function name, so that we have the first to be computed is this association here, and this is this has an argument void in this case. And these function pointers allow a great flexibility in the code. In short, they define a point in code where a function will be called, that we don't have to define on that moment which function will be called, and we can define or decide that on a later stage. And this will be important for your next work in the lab classes. Then we can make some let's say funny things with function pointers. We can have function pointers. We can have an array of function pointers. So this is a symbol. By using the star, this symbol is a pointer, and it is an array. So there are several of them. So these are function pointers that return a void and take two integer arguments, and then they can be called, for instance, add, subtract, multiply. And when I call this, remember these are all functions that take two arguments. The value of C here will define which function will be called. So we'll define the index of the array. Index 0 will be the first one, index 1 will be the second one, and index 2 will be multiply. You have an example also in the repository that you have been using. I can check out, it's called FP array. And if I show, this is the the example code of how to use an array of function pointers. Notice that I have here three functions defined: add, that prints the value of adding two numbers; subtract, prints the value of subtracting two numbers a and b; and multiply. I have here the definition of the function pointer array, as we have seen before, and then I define three values. This will be just for used for input, and then a and b, which have values 15 and 10. And then I stay in this loop. I read the input. It can be either 0, 1, or 2. Any other value will cause the program to finish. And if it's either any one of the 0, 1, or 2 values, it will print it will call the corresponding function. So let's just see this working. Again, code is okay. And now when I run this, if I type 0, it will call the function add. If I type 1, it will call the function subtract. If I type 2, it will call the function multiply. Okay, if I type 3, it will exit. So notice that this can replace, for instance, a complex switch. We could do that with a switch case, and case 0 run add, 1 run subtract, case 2 run multiply. But this is a different approach and with a different structure that can be useful in some time. So I can have several functions, and depending on the value of a variable, I can choose which function will be executed.